Inductive and magnetic proximity sensors. Let's get started. Inductive sensors and magnetic sensors are both types of sensors that can detect the presence or proximity of objects without physical contact, but they work in different ways and have different strengths and weaknesses. Let's first talk about their different sensing principles. Inductive proximity sensors use electromagnetic fields to detect the presence of metallic objects. Whenever a metallic target comes within their sensing range, it causes a shift in the field and activates the sensor. When the target moves away from the sensor to or beyond the inactive point, the sensor switches off. Magnetic proximity sensors, on the other hand, detect objects based on changes in magnetic fields. When a magnetic object enters the sensor's range, it alters the magnetic field, triggering the sensing process. Different proximity sensors can detect various objects in different ways. Let's take a closer look at what these two sensors can do. Inductive proximity sensors are primarily designed to detect ferrous and non-ferrous metals such as iron, aluminum, brass, and copper, but their sensing range may change based on the type of metal being detected. By contrast, magnetic sensors are specifically designed to detect objects that possess magnetic properties, like permanent magnet. The difference between the two types is that the inductive prox sensors will trigger on anything metallic, while magnetic sensors will only trigger in the presence of ferrous or magnetic materials. Another key difference between inductive and magnetic sensors is their range. The operating distance of the sensor is strictly linked to the nature of the material. In general, inductive proximity sensors tend to have shorter operating distances compared to magnetic proximity sensors, and they provide some correction factors in their datasheet when we want to detect non-ferrous metal targets. Compared with inductive types, magnetic sensors typically have a longer detection range, maxing out to 80 millimeters. These two types of sensors are also different in their sensitivity to environmental conditions. Magnetic sensors can be affected by external conditions such as other magnetic fields, severe temperature changes, chemicals, and physically unstable harsh environments, while inductive sensors are less affected by these factors. Following that, we've summarized the pros and cons of these two sensing technologies. Here are some advantages of using inductive sensors than the magnetic counterpart. The inductive proximity sensors are capable and versatile in metal sensing. They can detect metallic targets through non-metallic barriers. They also boast high switching rate, allowing for rapid response to objects in counting applications. In addition, they are also immune to dirty, greasy, adverse environmental conditions, offering impressive environment adaptability. Inductive proximity sensors are solid-state without moving parts, ensuring longer service life. As to their disadvantages or limitations, inductive prox sensors lack in detection range, averaging a max range of up to 60 millimeters. Although they're capable in metal sensing, inductive sensors are limited to detect metal objects, and using non-ferrous materials decreases their operating distance. In contrast to the inductive type, magnetic sensors feature the following advantages. Firstly, magnetic prox sensors do not require an active supply to operate, thus simplifying their design, reducing overall cost, and minimizing power consumption in practical applications. Secondly, magnetic sensors can operate freely through plastic and non-ferrous materials, allowing for sensing even across hermetic barriers. Thirdly, they are unaffected by dust, dirt, oil, or other contaminants that can damage other types of sensors, making them capable in harsh environments. And besides, they also have a fast response time in detection of magnetic materials. Magnetic prox sensors also have their own limitations. They are not suitable for directly detecting non-metallic materials that lack magnetic properties, and they can be detrimentally influenced by external ferromagnetic interference. Their sensitivity to other present magnetic fields can spoil measurement accuracy. To sum up, the inductive proximity sensor is the go-to option for detecting metallic targets considering their versatility, high switching rate, and anti-interference performance, while magnetic proximity sensors beat out the competition in terms of energy efficiency, anti-blocking capability, and adaptability in harsh environments. Now that we understand the differences, let's explore their applications. Inductive proximity sensors are widely used in applications where metallic objects need to be detected, such as security-related applications, and their high switching speeds made them popular for automation applications, such as product counting or sorting on assembly lines for automotive industry. On the other hand, magnetic proximity sensors find applications in areas such as security systems, door and gate automation, and position sensing, where the detection of magnetic objects is desired. Overall, the choice between inductive and magnetic sensors depends on the specific application and the type of material being detected. To understand more about these sensors, please refer to this comparison table. You can take a screenshot and save it for future review. That should do it for this video. Hope this video helps you to understand these two types of proximity sensors. Comment below if you have any questions. If you find it helpful, please give a like and share. Don't forget to subscribe and stay tuned for more informative video tutorials. Visit ATO.com to discover our latest proximity sensing solutions. Thanks for watching. Until next time.